Eric Burgess here, and we've been given the following problem and we are told to solve it. So looking at this, we see we have fractional powers, but we are already conveniently set to equal 0, so that's really nice. And there's a way to deal with these powers, right? So the goal is, okay, well, can we simplify this out? So keep in mind that 1/3 simply means that it's like the same thing as a cubed root. Like if we had 3x plus 7 inside of a cubed root. So we would cube it, right, to get rid of this. Well, on this one, it's kind of the same thing. You look at the fraction and you say, what do I need to do to this fraction to make it 1? So if we have 1/3, well, if we multiply it by 3, that's going to give us 3 over 3, and that's equal to 1. And that would get rid of the 1/3. So, but we also have this thing here that's been attached by a negative. So the first thing we're going to do is we're going to add this to both sides and move it over here. So we're going to get 3x plus 7 times 1/3 plus 4x plus 2 times 1/3 minus 4x plus 2 times 1/3. I'll move this calculator out of the way. We don't need it. And this is equal to, if we do it to one side, we have to do it to the other. So that's going to be 4x plus 2 times 1/3. All right, so these simplify to 0, and we are left with the statement 3x plus 7 times 1/3 is equal to 4x plus 2, not times 1/3, but raised to the 1/3. All right, so we've already discussed that, hey, you know, if we multiply this by 1/3, if we multiply this by 3, we'll get 1. And in other words, we just choose the reciprocal of the fraction. Well, the way we multiply powers is we raise them to that power. So if we raise this to the 3rd, and we raise this to the 3rd, because we have to do it to both sides for it to be equal, what happens is when a power is raised to a power, we end up just multiplying those powers. So we are going to get 3x plus 7 is equal to 4x plus 2. The powers go away because they become 1, and anything to the first power is just whatever it is. So now this is a much simpler problem. We can go ahead and move things around. So if we do a minus 3x to this side, and if we do it to that side, we have to do it to this side, and we'll move the 2 over to the other side. So we'll do a minus 2 minus 2, and what happens is these go to 0, these go to 0, and we're left with 7 minus 2 is 5, and 4x minus 3x is just 1x, or just x. Then we get x is equal to 5. Now, since our powers were odd, we actually don't need to worry about if this will work or not, because odd roots can have negatives in them. And the reason for that is, right, let me just show you an example. Say we had -8. If this was a square root, it would be not possible. We would need complex stuff. It wouldn't be very fun. But if we use a cube root of -8, well, -2 times -2 times -2 gives -8. And so odd powers can have negatives in there. There's like a quick example. So we've got 5, and now we could plug it in just to check that this is indeed correct, but we don't need to check it in case something screwy might be going on with like the roots or something. So let's go ahead, let's just check it for fun and see and make sure that we didn't make any arithmetic mistakes. So that's going to be 3 times 5, that's just 15, right? 15 plus 7 raised to the 1/3 minus 4 times 5 is 20, so that's 20 plus 2 raised to the 1/3. In fact, we don't even need the raised to the 1/3, because if these numbers are the same on the inside, then it's going to be the same number minus itself. So that's another way you could do it with avoiding the 1/3 entirely. But if we use the calculator, we see it checks out as well. And so we can even put a check mark next to it and say as expected. And that is how you can do this. If you have any questions about this, let me know. Subscribe. If you're a Citrus College student, feel free to stop by online tutoring. We're there to help you out. And we'll catch you in the next problem.